Hello everyone. In today's lecture we are going to cover function. In previous lecture we had completed trigonometry. In this lecture we are going to cover function. Again, function will study deep in mathematics. This is mathematics topic, but we are going to study basic about function. Okay. So we'll define here first what is function. Okay. So to define function, it is defined like that. It is rule of relationship. It is rule of relationship two variable between two variable in which one variable is assumed to be independent variable, and other one dependent variable. That means there will be two variable, and this function is a rule which is relating between two variable, in which one variable will be dependent, other will be independent. Okay. So for example, if I'm saying that y equal to, let's say, x plus 2. Okay. So we will call that this x plus 2 is function of x, and we will represent it like fx, and this fx and y both are same thing. Okay. This x plus 2 is function of x, we will represent like this. Okay. And in this one, this will be independent variable, this will be dependent variable. You can put any value of x, but you cannot get here any value of y. It will depend upon function. Okay. Like if you are putting 0, then it will be 2. It is 1, it will be 3. It is 4, it will be 6. Okay. So here this will be known as independent, this will be known as dependent, but both are variable. Okay. So another example, let's say I am saying y equal to x square plus 4. So this is again function of x, y equal to function of x, which is equal to x square plus 4. So this is again independent variable, dependent variable. We can write anything like y equal to, let's say, 3x square plus 5. We can write anything like y equal to, let's say, 4x. So we can write this one y equal to something which is depending upon x. X is independent variable. X you can put anything. Okay. So here this is known as independent variable, and this one is known as dependent variable. Dependent variable. Okay. So this is how it is defined. Okay. If I am saying that, let's say, another example, let's say a particle is moving with constant velocity, 2 meter per second, let's say. So we can say that displacement of particle is function of time. More time, more displacement. Less time, less displacement. So we can relate here displacement with time. Then if particle moves with 2 meter per second, then displacement of particle displacement displacement of particle, you can write particle is function of time. This f and function of time, we can write here s equal to 2 meter, so time t, so it is like s equal to 2t. So this is function of time. So displacement is function of time, that means time can be anything, 1 second, 2 seconds, 10 minutes, 15 minutes, 20 minutes. So you put time anything depending upon t, this s will be calculated. Okay. That how much displacement of the particle. Okay. So this is how it is defined function. So what is function? It is a rule of relationship between two variable. In two variable, one will be Independent like x, here all x is independent. Independent means you can put any value of x. This one is dependent variable. This dependent variable is variable, but it is depending upon this independent variable x. That's why we are calling this is dependent variable. Okay. So next, uh, we can learn about range and domain of a function, because sometime it will be used. Okay, so range and domain of function, range and domain of function. Okay, so let's say there is a function y equal to fx. Fx can be anything like x plus 1, x plus 2, x square plus 1, x cube plus something. Okay, so it can be anything. Okay, let's say x plus 1, x square, x cube plus 1. Okay, this anything. Okay, so y equal to fx. Okay, so here whatever is possible value of this x, that will be known as domain. Whatever is possible value, whatever is value of x, that is known as domain, and whatever will be value of this dependent variable, that is known as range. So here we can define domain equal to all possible all possible value of all possible value of independent variable. All possible value of independent variable is known as domain. Range we can define here. Range. Okay, so all possible value of dependent variable. Okay, so all possible value of dependent variable, all possible value of dependent variable is known as range. Okay, so this is how range and domain is defined. Okay, so for example, let me take one example. I'm saying y equal to, let's say, x square. Okay, so y equal to x square. Here what is possible value of x? You put anything. That means we can say all real number. You put any number there. Okay, so that is input. This input is independent variable. Independent variable here can be anything, but here we will not get anything. Here we'll get, it will be positive negative, but here we'll get only positive, because minus 1 square 1 square, plus 1 square 1. Okay, for minus 2 square 4, plus 2 square 4. So we are putting here minus plus, but here we are getting in place of y, that means x square only positive. Okay, so here this is all non-negative number. Okay, that means x can be anything, but this one cannot be anything. So here value we can write here. Okay, infinitive does not exist, we can write here anything, but here it will be 0 to only positive infinitive. Okay, so this will be like this. Okay, this bracket means this one is excluded, and this square bracket means this one is included. Okay, so this is how it is defined. Let's say another example. Let's take y equal to cos x. Okay, so what is possible value of x? So here domain can be all real number, all real number. Okay, any number you put there. Okay, minus infinity to plus infinity, any number, any angle you put here. But here range, it will be defined only in between minus 1 to 1. So output of cos x will vary only in between minus 1 to 1. Okay, it will not go beyond 1 and less than minus 1. So this is known as a square bracket. And a square bracket, meaning of a square bracket is that any value in between. Okay, and this one is included. Okay, so here minus 1 to 1, any value including including -1 and 1 also. That means any value in between and with including -1 and 1. If this is small bracket, then we can exclude -1 and 1. If there is square bracket, so we have to include -1 and 1 here. Okay. So this is how this is defined. Okay. You can take other example. One more example. Let's take. I'm saying y equal to let's take y equal to sin x. Okay. So sin x again, all real number just like cos. Okay, this is in between -1 to 1. Okay, so this one is range and this one is domain. Okay, so all real number is domain and between -1 to 1 is range. Okay, so this is how range is defined, domain is defined, and function is defined. Okay. So this function is also treated like a machine. Okay. So let's understand by few example. Okay, how it works, how this function is treated like a machine. Okay, so this part is over. So we are studying here only basic. Okay, this much is enough for physics. We will treat we will treat function as a machine. Function as a machine. Okay, so what is function of machine? Okay, general. What is use of machine? Machine means there will be one input and accordingly will get output. Okay, like let's say you are giving some input on keyboard. Okay, you are getting output on monitor, on display we are getting some output. So whatever input you will enter through keyboard, accordingly will get output on monitor. Okay, so hold this keyboard, machine, display means monitor, CPU, all this setup is acting like a machine. Whatever input you will give, accordingly output will come. Okay, so this whole setup is acting like a function. Okay, you have to give some input, accordingly you will get output. Okay, so here if I'm taking this one is machine, so machine means there will be input, and input can be nothing but independent variable. Independent variable, and here we will get output. This output is nothing but dependent variable. Dependent variable. Okay. So there is some process inside machine. This process means it will convert input to output. Input to output. So accordingly you give input, you'll get certain defined, certain fixed output only. Okay, so this is dependent variable. Like let's say I'm saying this is a machine which is acting like x square. That means any number you enter here. Okay, so here input, this is input, this is output. So here input you put x equal to, let's say, 0. So what is output? Output is 0 into 0, that is 0. You put x equal to 1. So what is output? Y equal to 1, that is equal to 1 into 1, that is 1. X equal to 2. What is y? That is up to, that is 2 into 2. So this is 4. So accordingly it will convert. Okay. So here I will put input. This machine will process it. Process means here this is given y equal to x square. So whatever number you will put here, it will make it square, and square is output. So this all input, this all output, this all independent variable, this all dependent variable, and this machine is acting like a function. Okay, so we can take another example again, like let's say y equal to, I'm saying, x plus 2. So this is machine acting like a function which is equal to x plus 2. So this is y. Okay, y equal to fx. So now again here, if put here x equal to 0, what output you will get? Y will be equal to f0. It will be 0 plus 2 equal to 0. If you put here x equal to 1, output you will get y equal to f1 equal to 1 plus 2, that is equal to 3. If you put here x equal to 2, so output you will get y equal to f2, that is equal to 2 plus 2 equal to 4. Okay, so here input you have to put, output you will get accordingly. Okay, so this function is also treated like a machine. Okay, so this is how. Next, one more example you can take. Let's say there is a sphere. Okay, I'm saying that radius of this sphere is r. Okay, so if radius I am increasing, of course volume of the sphere will increase, surface area of the sphere will increase. Okay, so here we can say if this is r radius and this one is sphere, so we can write here volume of sphere is function of r. That means we can write here v as a function of r. So this is how function, and this value is, this is equal to, 4 by 3 pi r cube. Okay, if I'm saying this is radius r sphere, so we can write here surface area of sphere is also sphere is function of r, because surface area again we can write function of r, but this will be different, 4 pi r square. So we will take different radius, we will get different volume and surface area. Okay, so like let's say find, I'm saying that find volume at one radius. Okay, volume when radius is 2. Okay, so we will get here volume 4 by 3 pi 1 into 1, that is equal to 4 by 3 pi. If I am taking this one, so 4 by 3 pi into 2 into, sorry, it is q. Okay, this is q. So this will be 2 into 2, 8, 32 pi upon 3, and unit is meter cube if radius is given in meter. Okay, this will be again 1 into 1 into 1, so it will be 1 only, so this is meter cube. So this is volume, how volume is defined. So we can write here radius changing, that is independent variable, volume will also change, that will dependent variable. We can write here volume is function of r, that is equal to 4 by 3 pi r cube. We can write here surface area is function of r, we can write here s equal to 4 pi r square. Similarly we can define, okay, so there is relation between two variable, this radius variable, volume variable. So relation between this radius and volume is function. Okay, and here this can be anything, volume cannot be anything. Although volume will dependent upon radius, but volume cannot be anything. Volume will always depend upon radius. Radius can be anything. So radius can be anything. That's why I'll call this one is independent variable and volume is dependent variable. Clear? So this is how function is defined, range and domain of function, and how this function acting like a machine. Okay, input, output. You give some input, it will convert into output. It will depend upon how is the process, how is the function inside machine. Okay, so this is all about basic of function. Okay, so in today's lecture we'll learn about function, range and domain, and how it is acting like a machine. Okay, so this part is over now. Next lecture will cover algebra and logarithmic, then we'll start differentiation. Okay, thank you so much.